spatial analyst, individual GIS person, and I'm trained geographer at the Human Geography Department, the Department for Social and Economic Geography at Uppsala University. Geography is, as a subject, extremely wide, sort of spanning from philosophy to the things we are doing here in terms of more spatial analytics and quantitative and math kind of side, but it all is in the same department, which is confusing at times, but also very rewarding. We don't simply know what the other ones are doing, and the other way around. But it's an interesting department. We are located in economics, economic of the building, where the other economic subjects. What did I do? Oh, there I did something. Sorry for that. So again, we are going to talk about the grammar of geography. We're also going to talk about geography as scale and how we can scale up computations. And with that, a very few notices, but still very important one when it comes to opportunities and ethics, because there's something peculiar that happens when we introduce geography into big data computations. And we'll see it when we do it, but it's really kind of difficult to, from an ethics point of view. And when we look at a few geographical theories and presentation of theories at the different geographical scales, and finally we'll end with a few questions that we can resolve using the methods that we will train on the later parts of this day and tomorrow. So this is the main idea. So a theoretical foundation for what we do, present you with a few ideas, and then we move on. So this is fundamental, very basic, but still it's important because very many individuals get it wrong. And this is something we have to correct as geographers a lot of time. It's also a matter of what words we use. So this is important in a sense. When we talk about space, we talk about something that is all the same everywhere. It's easy to measure. We could use cost, time, distance. There's no friction that ain't the same all over space. Everything's the same, everything. But when it comes to place, it is the opposite. It is always a unique location, and it's difficult to model since most of the qualities are culturally attributed. And this is important. So geography, when you look at this space, place kind of thing, it really places the difficult one. Because if I say to you that you might come, you live now in Uppsala, you have all different notions of what we mean with the city of Uppsala. It's not the administrative area. It might be the student areas. It might be the something else. And if you say areas in sort of that refer to cultural bond, Bergslagen, which is a mountainous area where you do iron oring and stuff like that in Sweden, individuals in the core area tend to have a smaller span of the space than the ones living in the outskirts do. So all these kinds of things vary, and our sort of notions of them, which means we can classify it, but it will be really tricky. We do it administratively, historically, culturally, but it's sort of, again, difficult. And where we place geography is in the intersection between these two. That's kind of what geography is doing, because space, everything's the same everywhere. That's kind of simple. We wouldn't need geographers for that. And if everything was unique, we wouldn't need geographers either, because there's nothing to study, because everything's unique, right? So we try to combine and learn from the intersection where we bring in spatial sort of spatial ideas and theories, and how to try to understand how the intersection or the interaction between places can occur. That's my interpretation of geography. There's, of course, as many interpretations as there are geographers, but since I am a geographer, I can say this is my version of the truth. And this is also often where we start our work, spatial models, intertwined with place. Why is some city doing better than the other? It's a matter of place, it's also a matter of interaction to others. If we move on, the grammar of geography, if you look for that intersection between space and place, we can sort of think of how to define an accurate measure of, for instance, an individual's neighborhood. If we try to define that kind of a space-place geography, what does it mean? We can have something that is crudely defined as an area. Think of your neighborhood. It could be the neighborhood, the ward, the output area, the block, the sams, we would call it in Sweden, perhaps, or the municipality. If we all aggregate the conditions or the qualities of the inhabitants on the sort of the average incomes and educations, we have a neighborhood statistics. But there are several problems with this kind of statistics, but it's still the most commonly used. And all the time you see these kinds of models saying this is the best school municipality in Sweden, this is the best industrial sort of region in Europe. They tend to be based on this and relatively often kind of very bad statistics behind it because it's really not what it's supposed to be. We can also see that kind of geography, how we define the intersection between geography and space as a Radi-based kind of thingy, where we place the individual in the middle, or the K nearest, where we have something like saying my neighborhood is always constituted by the 5 nearest individuals, 1, 2, 3, 4, 5. That's my neighborhood. What you do and what kind of economy, gender, social mix, or whatever we've got is what defines my neighborhood. And if we floating catchment move this around, so everyone has got the 5 nearest neighbors, we've got the neighbors that centers on the individual. The area centers on itself. The radius centers on some idea about the space. So these kinds of things are different ways of modeling and thinking of it from a geographical point of view. Oops, sorry, moving too quickly. If we move to the area-based one, and this is important, especially the second one. The first one is kind of self-evident. If you've got an area, you've got a problem with Boolean borders, or border effects, we usually tend to call it. If you're living at the border, you're part of the region you're in. It might be that this is a municipality border, but over here is another one. I'm not using any of that statistics or information for my understanding of what a neighborhood is, but of course it affects my decisions and my motives. And if we do things like cross-commuting, we have that as an instrument of how much interaction there is in an economy. Just assume that in one municipality, the central city is placed in the middle, and the other one is in fact placed at the border. Those kinds of things will affect the spatial interaction, not because humans behave differently, but just because we've sort of drawn the areas very differently. That second thing, which is terrifically important to understand, is this: MAUP, modifiable aerial unit problem. Geographers have good laughs when we look at statistics that has got this ridiculous problem, because we see so much crap coming out. And it's a sad thing, because it's so many individuals that don't know it. So if there's anything I just want to bring you from a sort of almost geography moral point of view, remember MAUP. And this is what it is. If you think of this as a city divided in 2 halves, you see you've got one green half, right? And you've got one white half. Let's assume that those are the poor ones and the rich ones. These could be the poor ones, these could be the rich ones, okay? And you have statistics defining the level of segregation in the city. And you find that you've got 100%, what was it, poor right there? Yeah, poor people there, and 100% of the rich people there. We've got a complete segregation in the city. It will be in the newspapers. The simplest way of solving the problem in the city is to redraw the line. By doing this, you have no segregation between the rich and the poor. This is what we see when we look at the statistics, where you've got the ranking of the best and the worst case municipalities in terms of how they perform in school and how they do these kinds of things. Because if you think of municipalities like the Greater Stockholm area, you've got municipalities that are there specifically for dwelling, specifically for work. So if you do a very simple measurement saying, well, the working municipality has got many employment opportunities, but few to compete for them, that's good for them. That's just crap, because people commute in, right? And the opposite, living in Djursholm is not a problem just because you've got very few jobs. It's usually the opposite. The very posh neighborhoods have got very few jobs simply because they can commute, they can afford the time and the money it costs to go somewhere with the less amenity that it means with noisy industries and transport and stuff. So these are the things we have to take into account. Simple, but it's usually forgotten. Here's a terrifically funny example of this. I love this image. I did the map. A Swedish agency made the table. The agency is long gone, so it's okay to show it. It's Statens Folkhälsoinstitut, it's sort of the public health department or something like that. what they did is they came up with a solution of the sales of alcohol, pure alcohol per capita. So the sales at the local stores divided by the local population. And the redder it gets, the more problem they've got with sales of alcohol. And this one municipality consumes 84 liters of pure alcohol per person and year. That's such a ridiculous number that it's just terrible. And you know what? They've got the problems there. And over here. Do anyone see the problem, the real problem? No. You know why you see it? Because it's in a map. You can see how silly it is. In a table of 290 municipalities, you wouldn't see it. In fact, what they do is that they recommend this municipality to take part of a program to actually reduce their alcohol consumption. So they get a phone call telling them, you've got a problem, and they go, what? You have to solve it, and they have to solve it some way, and where do you think they get their help from? Down here, which is there. Why do they have such a low alcohol consumption?
Denmark.
They buy it in Denmark because the booze is much cheaper there. So these guys are getting sort of happy messages. Congratulations, you are the best municipality in Sweden for taking care of alcohol problems. And they don't. Really? No. Absolutely no. Could you help us train these guys? They seem to be completely unaware of their problem. Sure, we'll do that. These are the things you will have if you don't treat geography and take these kinds of things seriously. And this is a public map. This is how things are being spent. So there's a serious side to it, right? It's a fun side, but it's serious. This one as well, Knivsta, part of the statistics, I took it 2012. They only got the Systembolaget on the autumn in 2012, so they didn't have the time to actually consume that much. But they did great in the region. Again, a silly statement. And here's another one, less funny perhaps, but still as important. If we think of things like county, very many times when we do these kinds of cross, the region, the size of things really is important. Think of a thing like sort of between county variation. We live in a county, Uppsala County, we've got Stockholm County, we've got other kinds of counties. If you compare things like unemployment, educational level, industrial mix, you'll usually tend to have no mix at all. And unfortunately, these are the nuts level we use in European level statistics, and that's what we tend to see more and more in Statistics Sweden statistics. The problem is that, of course, the variation is taking place between the types of municipalities. We've got one behavior in the regional capital, usually where all the skill is being collected. We've got unemployment, youth unemployment, sort of these kinds of elderly problems and stuff in the rural municipalities. So it all varies. So if we would look for the between municipality variation, you would have a significant result. But since much of the statistics is missing out on the sort of the general idea of what geography is, we tend to see results saying there's no variation. So this is, again, less fun, but just as serious as this one. We miss the message of space and place and how it's being intertwined. This is just a study we did once where we could show that the resilience, that regional economic resilience, it's a measurement, a composite measurement there. We didn't really work and understand how we could understand the unemployment and loss of population until we combined it with a measurement of accessibility and commuting. When we did, it suddenly made sense. And it makes sense, of course, when you talk about it, but you have to show it sometimes. This is the sort of critique and the idea about the area-based. I move now to the radii-based. The radii-based is something where you place sort of a fixed radius and you collect everything within it. This is actually because it was free data. We have problems with free data sometimes in a few years. It's better now. I took average cow production units in Sweden, which is an odd kind of thing to do, but nevertheless. How many cow production units do you have for, you could say 100, 200, 800, 200, 2,000 and 8,000 meters? And what do they mean? As you can see, I say something like shared market service, agglomeration sort of markets. If you've got a big site, perhaps you could have a storage facility that sells tools and provides service for your tractors and stuff. You've got plenty and these kinds of things. And this is what it looks like. I don't know if the color is can you see the variation, the pattern of variation? It's a noisy one. You see it, right? It's kind of noisy. You can see there's sort of color patterns to it, which shows that you've got some kind of a pattern. Well, there's a problem. If you do a fixed radius, you end up with this. If you place a radius of 10 kilometers around this building, is where the Nobel Prize is being awarded each year, or being in the ceremony. In the central parts of Stockholm, you'll have very, very many individuals. If you have the same radius here, it's supposed to be in the northern part of Sweden, northwestern, you will have a few reindeers and a fish. These kinds of statistics tend to give extremely variant, sort of high variation data sets. And this is just an exemplification. This is just a purely random seed where we sort of just distribute things and distribute values and then do a fixed radius. And as you can see, some of these areas are getting high cluster values, some are getting low cluster values, where you have one individual representing the entire group of individuals. And then you will have the extreme saying 100% of the individuals are unemployed. Which of course is silly, but still. There's another one, the k-nearest based one, and this is the same kind of statistics where we got it on this one. It's on 1,600 nearest farms. So instead of asking a meter, we asked for what's the share of cow-producing units within the nearest of 1,600 in this case. You get a much clearer pattern. But there are problems with this as well. It's used to be computationally demanding, but it also raises another kind of question we have to deal with when it comes to space. Do we really think that if we live in the northwestern part of Sweden and we're looking for 1,600 cow-producing units, that the 1,600 in fact is a neighbor in any respect? It might be located 3 hours away in a drive. So there are, regardless of what we do, fixed area, radii-based, k-nearest kind of base for the definition of space and how we see this being varied, we're going to end up in problems. One solution is to think of distance decay. I'm just going to give you a few kinds of ideas about geographers who have been doing this. Think of it in terms, and then I move to economists when I start talking about geographers. We tend to work quite a lot together, but think of sort of the reservation wage idea. Are you familiar with reservation wage? Let's assume that you are now sort of getting a job offering in Stockholm. And let's assume that it's not very well paid. And we go and we ask, are you willing to take it? You would say no. If we raise the salary, at some point you would say yes, because you see the benefit is greater. So the reservation wage, your reservation, where you are willing to accept the job offer, has got a price tag to it. So if you want to accept something, it's depending on the price. Think of that in terms of geography. Add geography to it. If you got the same salary, would you accept the well-paid job in Uppsala? Likely, yes. If it is being offered in Stockholm at the same price, sort of considering that you live in Uppsala, probably you would. If you go further away, say Malmö or Copenhagen, you will probably say no, because the cost of transport, the cost in terms of time and the cost of knowledge and rehousing and these kinds of things will make it less favorable for us. And these are things we've seen kind of a lot. If we have decay parameters that could be found statistically and mathematically, we've seen sort of different models. I'm afraid the color is not moving, it's not working for me really here, but I'd say that's kids' movement. We usually use exponential, negative exponential normal curves to display how those works, which says if we got, this is 0 meters and this is sort of very long distance, could be almost eternity, we usually see a probability of accepting a school or going to a friend that's got this kind of a distribution. You're really likely, very highly likely to accept a job offer up here. We set 1 for 1 probability, and then it just sort of is very low, because as soon as you move 800 meters from home, you start not recognizing the people. You don't know what routes you are. Mummy and daddy will be frustrated and things like that. So it will probably not happen. When it comes to commuting, 800 meters is not an area, it's not a thing. The only thing you have to think of is to get the parking, to know the colleagues and stuff. So we usually model that using a negative exponential model, which gives you something like this. And if you think of it in terms of migration, if you really want to migrate, Is that a really big difference between 100 meters and 100 kilometers? Not really, because the real cost is in the migration decision itself, which means that the power distribution of some sort is more likely the event. You see the distribution, so the shape of the lines and how we decay the spatial behavior also has an influence on how we could model space and how things are being sort of in it. We usually do it sort of nowadays mathematically because we are sort of lazy, because we can use the carbon-14. Oh, I can have this instead. Sorry for that. The idea about half-life. We got half-life carbon-14 at the sort of half, at some time span, you have consumed half of the carbon-14, which is an isotope that sort of loses radioactivity, and the rest is there. So using sort of an integral math, you can sort of understand how to do a sort of calculation in exponential, sort of negative exponential models, and actually do it also for commuting. Because it's not half of the radioactivity, but if you've got, for instance, the labor market, you've got half of the commuters have commuted to this distance, the other ones are commuting further. So the median commuting distance could be as it is for the half-life in terms of carbon-14. So you can use that to derive a sort of an approximate value for beta value in terms of commuting. So these kinds of things could be used to make sort of quick things in how we could model up. But we can also, of course, test it on a big data set and do it pooling around, looking for all the neighbors. How far are the 1,000 nearest neighbors commuting? Can we derive a local beta value that corresponds to the behavior we've got? These are just ways of thinking. I'm just getting you into a mindset of thinking of circles, areas, radius, and ways of thinking about the intersection between space and geography. Any questions so far? Am I talking too quickly, too slowly, too oddly, too geographically, too lead anything? It's okay? Okay. So, we got a few geography scales that will go over to the theory very soon as well. We could think about the geography scale as something like context and neighborhoods, where we put the individual in the center as an urban-rural kind of scale, where we put the company or the service provider in the center, and we can think of it as a region-nation, the state firm in the center. So as you can see, when we are dealing with geographical problems, we have the problem of the individual finding something. We have the problem of a school having kids, getting kids into the system. And we have something like the region trying to make an economic living. All of these scales could be scaled up computationally, but also have a geographical and a temporal scale that we have to integrate in the model. So we'll start with the first one and think of this. And here's a completely new way of seeing geography and scale, I would hope, for you. If you think of context and neighborhoods where you put the individual in the center, you would quickly realize that there's no one geography. There's not one neighborhood. If you depart from the k-nearest assumption of the individuals and the neighborhoods, it's kind of easy to say, it says there 12. Those are the nearest neighbors in your house when you meet them in the morning. Those are the ones you can have a friendly chat with, that you can ask sort of, what's your dog, or water your flowers and take care of something, or brush your front if there's snow to make sure that you're home when you're not and stuff. These kinds of things. You got 25 in the bigger building, sharing a laundry room, you got a block at 100, a bus stop at 200. You see the services and the frequency of interaction with individuals is organized very many times on the number of individuals. We don't organize the number of schools on meters. We make them organize them according to the number of individuals. So at some point you'll have a kiosk, football field, small shop, what does it say there? Daycare school, local square, upper secondary school, hospital, place belonging, municipality, these kinds of things, right? So any geography is in fact best produced multi-scaled. So if you place you in geography, you probably have 100 different geographies. You're part of a region that you, in your heart, define as your home region, your school region, your commuting region. All these neighborhoods affect, by their frequency, the individuals you'll meet and the opportunity for you to make elaborate choices in the future. Because the one you meet actually is going to affect your voting behavior, the way you sort of spend your vacation, the way you marry, everything is that kind of of spatially bound in these ideas. Back in the days, this is an old British example from the 19th century. Ebenezer Howard that was trying to do the first sort of perfectly planned city. It's very interesting. It's got kind of words of asylum for many different kinds of routes we wouldn't use today. But the general idea is to depict a city that has got all its functions. The distances to the core, to the school, to the neighborhood, to the water, to the nature. Everything is designed to fit the needs of individuals at a multi-scale level. So this is the individual, right? If we think about it from a sort of a regional point of view, there's a traditional one. Von Thunen is an old sort of economist that did it on the agricultural, sort of how we did production. Where did we have the dairy products? Where did we have the grain and stuff? We could forget it a little bit, but Alonso is a much more sort of recent economist that have been discussing where do we have industry? Where do we have residential areas, and how do we understand the cost of renting from the city center as a bid rent function, where we see the supply and demand and how the cost is organizing, self-organizing, what kinds of activities is being offered at different distances. So the self-organization on a local urban level is also a geographical phenomenon. This was modeled by sociologists, in fact, in the 100 years ago. They had what we call the concentric model that has been discussed very many times, and very many of these models say we've got a CBD, central business district, and it grows out, and we have different sets of kinds of geography, the dwelling areas, the posh areas, the industry areas and stuff. In fact, many of the cities have got this design today. It could be related to this. It could also be that it's more plan active. So planners have more actively taken control of the city, making sure that the design of the city following certain principles. Especially in the old-fashioned city, what was the case? Because the noisy industries was something you wanted to separate from individuals' dwellings. So there were regulations and rules. And things like the first plans in Uppsala and other cities, usually the first they solved is where to have the graveyards and the relationship to schools and dairies and stuff, so health and sort of odd things perhaps in a way, right? But now this is affecting migration patterns, demographic also today, because we've got baby booms. Some years, Sweden is a good example of that, having generations of many high birth cohorts and lower birth cohorts and higher birth cohorts, and if everyone in one generation is trying to find housing at the same time, it's going to do something with the market. And then a few years later, it's going to do something else. But it's also going to have a spatial effect, because many of the individuals at times will try to crowd at specific units and specific locations, and will have specific sort of locational requests that will not be there 5 years later, purely due to demographics. So it all intertwines. And this is finally the regional national one. That is supposed to be a what is it called? Animated GIF. It doesn't work here, I see.
Yeah, I just slapped all the PNGs together. I didn't realize.
That's okay. Then I explained it. If we have it as a hexagonal pattern, but you see, I draw it instead. The Cristalla kind of. Hope it's not going to. This is a horror movie, perhaps. No, it's not. It's working. That's good. See it as a function of what you want to have. How far would you be willing to go to buy a sausage?
Oh, wow. 500 meters?
500 meters. It's a good and relevant question. I'll return to why soon. How far would you travel to have sort of a serious condition, sort of medical condition treated? Is it more than 500 meters?
Definitely, yeah.
You could go into another country.
Yeah, probably.
So, if we think of those kinds of things, those are the two extremes, right? Well, I wouldn't say sausage is an extreme, but nevertheless, I mean, the providing of services of some kind are sometimes very local, less frequent, even less frequent, and extremely unfrequent, and very rare. We hope never to see them. And these kinds of things tend to be organized spatially in a way that sort of distributes the services in a hierarchical fashion. And this is also determined kind of to be self-organization. There are laws that are being used, mathematical ones, Zipf law, for instance, but usually we refer to the Cristalla because it also comes with a geographical concept of how it's being organized, where things like the main capital is over there, and those have got capital functions that do not exist anywhere else, which means that it's got a specific size. The other cities will be around like this, and these cities will then have satellites surrounding them, and each of them will have satellites. So if this is where you went up in the morning, this is probably where you go to your grocery shoppings, and this is where you go for the university studies, and this is where you go for the labor market potentially later. If you look for countries like Germany, but also Sweden, many parts of Northern Europe, they tend to be organized like this. There's been immense critique against the models, but many of them says that if you got sort of, if you think of it more as a theory than reality, it actually makes good sense. And then, as always, geography or place is going to make it difficult. But this is a very spatial model. If you have a big lake or a mountain range, it will not work because people will not commute that way. The really sort of the interesting threshold here is the minimum market needed to sustain one activity and the maximum distance consumer are willing to go. But take those two into account, and there's a spatial model in the making where we can try to realize how far and under what kind of restrictions individuals would be likely or willing to pool up. And using big data, we can also pool up where they are 24/7. So time, activity, volatility, all these kinds of things could be communicated into one big model that could be used to refine the central place of the regions. And now I move to the next section. Geography, what do we mean by geography? What do we mean by scale? And why should we scale up geographical studies? And there's literally lots of warnings in this, more than anything else. Place, not space, makes it difficult. For example, in a transport study, it's usually solved through surveys. If we've got a survey analysis of how people tend to want to commute, it's easy. We just ask sort of age, socioeconomic index, agenda, and we look for things like availability to transportation, things that haven't got a place to it. It's just sort of conditions and qualities. You can do it with 10,000 individuals, and you can generate the statistics telling you the difference between different kinds of categories. But as soon as you include an origin-destination matrix, say the Swedish municipalities of 290, and think you want to have something like the 290 times 290, so you have a full matrix of all the combined versions, you'll find that less than half actually have one single flow. The majority of the type value would be 0 or null in communications. And what happens from an ethical point of view is, of course, that we should not. It's extremely difficult to do to produce statistics where we've got one individual because we will be able to identify the individual at hand. So when we are scaling it up mathematically, it's both an opportunity, but it's also an ethical challenge. If we do it with discrete register data that we tend to call big data because it holds 10 million observations or so, it's a problem. Could we solve it, or could we treat it in the other direction? Depends on how we want to do it. See it this way. If we have an individual and we see that the individual starts in the morning here, you see my red point, and it moves there. That's Monday. This is Tuesday. This is Wednesday. This is Thursday. This is Friday. Sorry for that. I had to do that. And this is Saturday. And this is Sunday. And the next week is the same. Now we know, just by the way I did these trajectories, is this one is a regular commuter, 9 to 5 kind of individual, likes to have a drink on Friday evening, is staying in bed on Saturdays, and go somewhere. Combine that pattern, you'll find a small village with 500 individuals, Okay, out of those 500 individuals, who commutes to that city and likes to have a drink on Friday evening? You see the problem, right? So the trajectories we want to follow also generates a lot of ethical issues that we have to sort of detach. We have to detach the individuals. We have to separate the individuals so they become sort of one individual. This is the clear Monday pattern. And then we look at all Monday patterns and see how they behave, for instance, and try to make a rule. But we have to be aware, because if we are not, we will be sorry. Be smart in selecting or be sorry, because very, very soon we have GDPR and other regulations. They could both be extremely expensive, but also be very bad from an ethical point of view. So we have to have that in mind, especially when we deal with geography. Because this is where the problem enters, I would say. Right. Is it okay if I just take a sip of water? 2 seconds.
Yeah, sure.
I'll make a geographical move. Oh. I needed that, talking too much. Oh, grazie, thank you. Right. So we return now. This is where I'm trying to make a few examples and questions that we can revolve around when it comes to the next levels of teachings. And I return to the individual level, the neighborhood. You remember it, right? And to the neighborhood level, urban level, where we have sort of the city. So from the individual to the city, and here to the region. So we're going to try 3 different concepts, theories that are being used, and also big data specific questions that we can try to answer. And those are named on individual level. We've got a very rich tradition in what is being called time geography. And in sort of this kind of neighborhood level, we've got a theory called spatial mismatch, and we've got another one called functional regions. So these are actual sort of theories in geography. This doesn't look well, does it? It's a big mistake, isn't it? That we're always trying to make everything part of one presentation. But nevertheless, this is a story about Torsten Hägstrand. He was a geographer from Lund. He made a very important contribution in that in the 50s and the 60s, where he was trying to model up the behavior of any individual and how the spatial and temporal behavior of an individual could be restricted to the places we could and could not be in. Think of this position at this very moment when I'm talking boringly. Many of you would like to be somewhere else, but you can't. We could see it as a restriction or as a constraint. We share space. You can't be somewhere else. We are here, right? So we've got capacity constraint, limitation of the activity of individuals because of their biological structure or their tools they can't command. Think of things like kids can't be awake for all times. We can't be, we need to sleep at some time. We've got a 24-hour window. The geography and the spatial rules of how we behave are restricted of biological and sort of physical rules and settings. We've got coupling constraints, limitations define when, where, and how long we could be at specific times. We cannot, even though the calendar suggests so sometimes, we cannot be in Stockholm at this very moment. We have to be here. So this is the case, right? And authority constraints, we might not have access to a specific locale because of so many different things. He did something interesting, Hägerstrand and his followers. They described these kinds of concepts with a new geographical notation called space-time prisms. Oh my, doesn't look. It's supposed to be a sort of 3 to 4 dimensional, but 3-dimensional graph of one individual sort of movement in XY space, and the Z level is time over the day, where you see. And those kinds of prisms.
Let me see if I can.
Oh, that would be great. Thank you. It's always the case. The projector is always on.
Huh?
Is there anything I can do?
Oh yeah, here. Oh yeah, thanks.
Oh, that's much better. So, could I just keep you there, Ralph, for a few seconds?
Yeah, tell me what you want.
Thank you, thank you. You see this, right? This one is a good one, in fact. You can see this is the complete area the individual is moving over the day, and the first hour the individual is stationary in the home, probably sleeping. And then this prism is showing the potential area the individual could be in. It's not showing the real area, but the prism is like a fish tank saying that within this time span, the next hour, I could be anywhere. You could burst out of that window. You could run out of here. The likelihood is probably little, but you could. The shared space, the space you could experience, is limited only by your legs at this very moment. And these kinds of things define a space that works in these kinds of three-dimensional models. So, see it as a probability rather than sort of a fixed area, and put these together with each other. So you've got intersecting probabilities of having co-presence with individuals in space. Those co-presence in time or space could tell us something about what kinds of individuals, what kinds of places have an increase or decrease in denominators, if you like, for crime, or the potential for markets or whatever at different kinds of locations at different times. This is simply the grammar, the theory behind how we do this, and the literature is really, really rich, and it's also tend to be kind of quantitative. At this point, I'm just showing the rough example. Thank you, Ross. I think this is...
Is this a co-presence example? What is this?
It might be. It might be. I just took a screenshot of the images I've got, but I think there's something more about it in follow-up slides. Thank you. Thank you. And this is again. I'm using sort of a Wikimedia material. That's why we got the Chinese. So it might be Japanese. Yeah. Sort of spellings and stuff. But the thing is the same here. You see the prism again emerging, and you've got different sets of things that we can see: constraints, bundles, and stations. These are things that have turned out to be very useful in spatial modeling, where you see places where you've got more or less restrictions. Schools and facilities that could help to bundle up individuals in their diurnal activities, that makes it easier for us to understand what in the groups of individuals are in fact co-present with each other and stuff like that. It's a common thing to talk about it as a space, time, or activity space kind of connotation. And if you want to know more, it's just to say that space, time is your geographical grammar. It depicts a potential for interaction. And if you go for the activity space, it is the fact, which is the next you'll see, is the observed geography, what we actually see people doing. It depicts the observed. It's also usually coming sort of when depicts the observed trajectory of individuals. We do it traditionally with our student as standard deviation and ellipse. Think of things like having a GPS recorder where you record every second of your activities. You're trying to find sort of the area where you got 60% or 80% of your space within one ellipse, and try to see something about the spatial. Then you've got these kinds of activity spaces that you can share and overlay with other individuals. You could of course do it in very many different ways, having a minimum convex polygon giving the outline of all the areas, or just take a path buffer, say that wherever you go, take 100 meters in each direction and make that the activity space. There's no limit to how these could be sort of modeled. But these are the differences. That this is more like the grammar or the theory, this is more the way we measure it. The questions that could be sort of put forward to this kind of material, we start with the data. Think of time-coded GPS trajectories or equivalent. Could be phone data, GSM data, public transport data, and these kinds of things, right? from a vast number of users, millions perhaps on a daily basis, where you've got also GIS layers depicting land use, networks, objects, schools, supermarkets and restaurants, etc., and contextual discrete data describing population. Say that you want to know these kinds of key nearest neighborhood contextual, saying, well, during the night, you tend to sleep in an area where you've got highly educational individuals. And then you could do another kind of study saying, how do highly educated people tend to behave in terms of commuting distance? Well, they tend to commute like this. Then you can superimpose that kind of statistically determined behavior and put it into a spatial context where you have too few ends to actually say something sort of from the local community point of view. So you can see, or you can use these kinds of very many different techniques to enrich the data. Then, do people, from the questions, do people from different walks of life meet? When? Where? If we have individuals from the rich areas, from the poor areas, where do they meet? When do they meet? How do we express this statistically? What's the likelihood? What's this sort of all these kinds of measurements? What kinds of systematic variation in activity spaces could be observed? Systematic variation in activity spaces. Is it something that follows time, space, or the scale towards from the urban to the rural? Is it long? Is it circular? What's the shape of these kinds of things? And could they be connected to time geography constraints? I didn't tell that and stress that much, but see it this way. If you got a highly educated bachelor, that time geography is usually extremely free. Then on the other side, you usually place a single mother in a distressed neighborhood. The geography, the stress is only there to tell you something that comes in the next slide, lack of transportation modes. So the activity space of an individual that has got just as much time and kind of just as much geography at their hands is also affected by those socioeconomic activities. So what kinds of, let me see, how do different categories of individuals use space? Single mothers, single fathers, highly educated, lowly educated, segregation kind of measures. Could we even talk about segregation? Could we use that kind of a measurement to see? These are things where we take into account the full diagonal mobility of individuals. We see where the potential for co-presence. There's so many interesting questions. Now I move from the individual level. Have you got any questions, by the way? Okay. Move from the individual level to the neighborhood, urban kind of level, and the next set of the data questions to be answered and the result. This is a classic one. Here's an economist called John F. Kane, came out with a very interesting paper in 1968 on the spatial mismatch hypothesis. And the hypothesis very sort of shortly could be described as the poor residential areas in downtown Chicago experience job loss. Job loss is observed, job growth is observed in remote suburbs. So we've got a mismatch is where it's needed and where it happens, right? And to meet the demand, long commutes are necessary. So this is the setting. Now what happens in this is that the negative spiral begins with a reduction in accessibility to jobs. Say that you've got a closure of a shop in the downtown area. So one more individual loses his or her job, so less tax money to the local community. The tax money is used to finance buses. That means a reduction in the service of the buses. As the reduction of service of the buses, there are fewer trips. As there are fewer trips, it fits worse for the local community, so fewer individuals will be able to commute. So instead of having perhaps a 1.5-hour commute, you're suddenly up for a 2-hour commute, and then you can't get the kids at the daycare. You have to be unemployed. If you're not moving, then the observed pattern is they don't need commuting help. They don't need public transport. There are less requests for transport, which leads to less money for buying things in the store, which means an extra store is shutting down, which means less taxation money, even less buses transporting people, making it even less affordable for individuals to commute. You see the negative spiral, right? This is a hypothetical example. It's been debated heavily. The development leads to increasing poverty and the closing of local services and so forth and so forth and so forth. And loss of course, social capital, because no one knows where you can get jobs. no one with a higher education. Even though social capital is known to be the capital of the poor, there's a limit to the relationship, the positive relationship. So, reduction in out-commuting, marginal in-commuting, that's what we are likely to see. Little variation in destinations as places, because you've got limited choices and you don't own your car, so the only place you go is there, kind of, eventually. Overtime reduction in local jobs and service, limited in-migration and limited out-migration, and stuff like that. The questions on this level is, can we detect neighborhood mobility patterns that are pointing towards spatial mismatch? And can we detect an order of events? Say, for instance, do local job loss start a negative spiral, or is it sort of the other way around or something? So the egg or the hen, what's the first here? The causality behind the negative spiral is important. But could we detect neighborhood mobility patterns that are pointing towards spatial mismatch? The classic one would be this one. I'm moving here again. In the morning, person A moves to the central part of the city, then moves out. In the afternoon, moves to the central part of the city and moves back. This behavior is known as an overcommute. It's clear that the individual would rather go this way than this way if he or she had the opportunity. If we have a very large number of individuals that do this, it tells us something about the opportunity for mobility they've got. And if we see a long-term trend of that individual doing this the next day or weeks or month, we start seeing these kinds of patterns. So these kinds of things are very important, because if we have this, we've got a deviation between potential transport and observed transport. And that's the key for understanding integration and segregation in society. We can't just look at what the people are doing. We have to look for what the potential of doing things. Do you understand this? Am I boring at the moment? Good. Well, it's okay, I could be boring. I'm sure I can. My wife and my daughters tell me a lot. Functional regions, the next level of it all, right? The super level. Functional regions should be constructed from observed interactions. In Sweden, that's supposed to be Sweden, usually based on data from OD matrices. This is what we usually have. So origin-destination matrices, where from taxation registers, where we've got people living in any location O, and they working any location D, destination. And these municipalities tend to be clustered then as local labour market areas. In Sweden, they are known as LA or FA. This is a link, in fact. I think it's online is a better one, and you can click it. I will not read it out loud. And unfortunately, the link is in Swedish. Thank God for Google Translate. Questions. Can we depict regions using the mass movement of things during the day? I mean, this is discrete annual data where people are supposed to live and where they're supposed to work. I can tell you this much. There are very, very many young people that live in Umeå or Luleå, far up north, but work on a hamburger restaurant in Stockholm. And I can tell you that's not worth the commute. But this is the official statistics. They live in second, third, or four-hand contract in the central parts of the city, and they are officially written with their parents. That kind of statistics is just messing up the way we see things. It's much better to see the general mobilities of how people in fact do behave. Are there time seasonal or time or seasonal differences in the way we can see regions? Have we got vacational regions? Have we got weekend regions? Have we got sort of the ordinary weekday regions? These are important questions that could be used to understand how we can organize bus and public transport, or I don't know, cultural events and these kinds of things, right, in a municipality. Can we associate destinations with activities and consequently refine our knowledge about the central place theory? That's why we started in the first place. If we see rare mobility flows, I mean, we live in Uppsala. Sometimes we go to Stockholm. We don't perhaps live in Uppsala, but I live in Uppsala. Some of us move to another major city like Stockholm or Linköping or Örebro or Göteborg or something like that in the Swedish context. Why? In some of the cases, it might be for a university, it might be for a hospital, it might be for something else. The prolonged and unusual sort of destinations and origins are also interesting. But thanks to OpenStreetMaps and other kinds of services, it should be feasible and possible to associate origins and destinations to kinds of places and types of places and see if there is any pattern in the deviations and structure in how far and what kinds of regions people are willing to commute to for different kinds of activities. That will tell us a lot about the organization of the crystalline kind of space. Is it the very short, the little greater, the sausage saying again, right? I mean, the sausage we see every day, the typical sausage behavior. But we don't see the rare behavior. On a collective general scale, we will be able to pick those kinds of things up, because on a daily basis, there will be people going to hospital. I stop here. Am I on time? Am I overdoing time, or what am I? I'm supposed to stop at...
Yeah, you have like 26 more minutes.
I got more slides. I'm sorry, I'm talking too quickly, I realize.
No, we can also discuss about things.
That's good. That's good. I'll have a few slides that we could show to actually address the issues and stuff. It says, I stop here with maps that could be used to exemplify our fascination for our field. So it's not just one, but it's a few. This is, in fact, a K-nearest neighbor depiction. I hope it sort of makes its way, but because I think it's interesting. It's an age-specific fertility range, a so-called HSFR map of Sweden. It's taken in 2008. What I did in this specific case is that I departed from each specific woman in various kinds of fertile ages, and I looked for how many of these surrounding females from each of these females had a child in the age span of 15 to 19. I did the same for 20, 24, 25, 29, 30, 34, and up to 45 to 49. Demography is part of the geography kind of trade. So this is, if you combine this, it becomes a new measurement called total fertility rate, TFR, which is used in the UN and other kinds of countries to tell us something about the potential number of kids a woman gives birth to on sort of a live basis. The thing is, that's usually being presented on a national level. This is on a female level. It's a completely different scale. So what we could see from using these more refined statistics, when we move away from the counties and from the nations and from the municipalities and the area base, and instead look for the individual-centered behavior, we see patterns. And this is interesting. We can start here, in fact, for the age 35, 39. Over here, we've got very little fertility going on, but this is Uppsala, this is Stockholm, this is Gothenburg, and this is Lund, in fact, not Malmö, that stands out. And the reason is that the childbearing career starts much later among female in the major cities and the higher educational cities. Because we do go to universities, we train, we do these kinds of things, which sort of increases the age for where we start our childbearing traditions and not traditions, behavior. This is, the red one is over here. And if you look here, the opposite, you see very low in Uppsala, in Stockholm, in Gothenburg, and in Lund, because when we start seeing an increase in giving birth to children in the age of 20 to 24, it remains very rare in the major central areas, just because we've got another behavior. This is one example of how we can treat geography. Here's another one.
Excuse me.
Yeah.
Going back there, have you any thoughts about why there are, if you have this age span 35 to 39, why there's this red area around Åre and Östersund?
This is the people from Stockholm. We tend to see a behavior in amenity-rich areas, and Åre is one case. Also, Gotland is another one. I was actually looking here as well, but it's not very clear. We do have a behavior where we can see that the areas under Stockholm in this case, which is in fact Åre and parts of Gotland, because there's so much economic investment, there's so much individuals that actually reside there. They decide to move out of the buzzing city. You know, they choose a new life, and this kind of behavior is going to affect the behavior. You see it when it comes to economy, you see it when it comes to economic resilience. Åre is in fact always standing out, but it's also very similar to Stockholm. Like it or not, I don't know. I mean, it's interesting. It's interesting. Another pattern is here, of course, where you could, these kinds of areas you really could see it's highly correlated to sort of youth unemployment in some sense. Not necessarily here, but there are certain. I did this correlation, but I didn't present it anywhere. We have a very high correlation between youth unemployment and high sort of teenage fertilities and post-teenage fertilities, which makes sense, of course. But nevertheless, it's interesting to see.
But that's where all the milk-producing regions were, right, in the previous.
Yes.
Is that more rural? Farm?
That would be fun if milk production.
No. Farm, rural.
No, but yes. Let us return to that one. Yes, yeah. Here's the high cow production areas here. Yes, but you do have child fertility over here. No, oh God. Let me see if we move forward. Not very clear pattern, I'm afraid.
But you have also a red area in like Nynäshamn or something like that.
Yes.
Which is
we do.
Stockholm.
Yeah. This is also interesting because I don't have these mapped with me, but it's a very clear-cut area where you've got the Stockholm region, the local labour market region. When I've done this for commuting statistics, the ring that I encircled is where you see commuting. Just exactly outside, that's where commuting stops. And that's also where you have a different fertility. So there's always that cutting sort of, I mean, there's statistics suggesting that 45 minutes is the typical time people would suggest as normal for commuting. If it becomes more than that, people are not willing. But if you could reduce it to 45 minutes, this is, of course, very generally speaking, right? But still, so at this point, you've got too many minutes, so people are not really interested. They become more local. This is another one. The benefit of using these kinds of novel techniques where you have multi-context and stuff is that you can start comparing over time. I'm afraid it doesn't show well, but this is relative poverty on multi-scales, and this is 12,800 nearest neighbors, I think, to have a regional pattern. And this is 1994, and this is 2010. The coloration is the same. It's the same color scheme, but it shows the concentration of relative poverty over time. And the only thing that happens is that you can see there's a strong concentration of non-poverty here, and it's a strong concentration of poverty in specific neighborhoods that weren't there 20 years before. What is it? 16 years before. So these ways, I mean, regardless if municipalities change, redistricting of things change, all these kinds of things change. But if you look for the nearest neighbors, you can start comparing things wherever you are. This is in fact what we are doing here, where we are comparing spatial isolation and segregation between Los Angeles and major cities in Sweden. And we can do so simply because we are comparing individuals. And this is interesting because it says something about the concentration of segregation, and it reduces over time. So, it reduces over the neighborhood size. So the likelihood of meeting someone like ourselves is greater, very close to us. But if we expand the neighborhood, 12 nearest, 25, 50, 100, 200, 400, 800, 1600 nearest neighbors, the likelihood of a more sort of entropy of people is greater. But close nearby, the sorting according to the pricing or the housing market and stuff is going to give us more kinds like ourselves. But this is interesting. It says something about the segregation. So there's not one level, there are multiple levels. And this final map is to show you that some of the things we've been talking about has already been done. This is a paper that recently came out in Environmental Planning A, where we have the level of segregation from a time geographical point of view, the first of the individual levels. What we did here is, me and Marina and Ebba over here, we've got a data set where we've got, well, between 1 and 2 million telephones on a daily basis that we can sort of see where they move. And using those phones, we rub in the socioeconomics of where they are during night. So we know what kind of neighborhood they live in during the night. And then we move these phones around over the day, and we've got 5-minute intervals. So we know where they are at every 5-minute interval. So 288 sort of positions over the 24-hour window. And that means that we've got co-presence, that we can see what kinds of individuals they meet and how they affect each other. And at the end of the day, we can sum up the experienced segregation of these individuals and see what kinds of individuals did they meet, and how did this affect, and how does it compare to the traditional measurements of residential segregation. And it actually suggests here, this is poverty, and this is wealth, and this is Stockholm. This is poverty, this is wealth, and this is Gothenburg. I'm afraid I only take the 2 biggest cities here. The redder it gets, the stronger the concentration of wealth, poverty, and poverty. These are traditional sort of residential patterns. We know them all too well, where people are rich and where people are poor according to the maps. These ones, the blue patterns, suggests areas where segregation of the poor, in this case, and the segregation of the rich, in this case, poor and rich, but in the other city, has increased due to mobility. So the blue is an increased segregation, the brown is a decreased segregation. And we have to see what it is. So in the poor areas, we have an increasing segregation of poor people over the day. So in some areas, segregation is being reinforced. In other areas, it is being decreased. So fighting segregation and increasing integration is not something we could just do by talking about it. Also to observing where the kids go to school, where people meet. Does school choice affect how the society looks? And I could tell you it does. The school choice has a tremendous effect on what kinds of individuals meet, and where we do our grocery shoppings and how we commute and all these kinds of things. Planning infrastructure, redistricting things in areas and schools will have an effect. And this is one way of showing it. But I'm sure we can do much better than this by refining the technologies.
I'm not quite sure that I follow what I do see here.
Yeah.
If you can take an example, to take the second one to the left lower picture.
That one?
There. And you have, you were mentioning Djursholm before, you're pointing at the brown blob, which I think is Djursholm.
I'm really, really bad at Stockholm geography, I'm afraid.
Up a little bit, and then there you go, and there to the left. That one, right?
Yeah, yeah.
How would you interpret that blob there?
There's two things that might happen. The brown in this case indicates then that you've got, let me see if I do it right, this is wealth. So you've got a reduction in segregation due to wealth. And I can tell you there's a paper on this which is interesting. And it's got to do with the effects of the extremes. If you got a distribution from, let's say that you've got a wealth distribution, let's assume that it's kind of normal, that's the most normal I can do, sorry for that. And this is the, let's assume this is where these kinds of individuals live, right? The really, really rich ones, they live here. Those kinds of neighborhoods have very few working places. They're residential areas only. And the ones living here are more isolated in a way from others. What they've got, one exception from all the other areas, is that you've got an inflow of handy people and other people that come to clean their homes and do other kinds of things. So I've been doing, not for this area, but for another area, we see that you got more rural to urban interaction, because you've got individuals that work in carpentry and plumbing and redecoration of houses. It's relatively big scale things happening in many of the richer neighborhoods. And those kinds of individuals don't live there during the night, but they come in. But they usually don't live in the cities. It's relatively easy to, in fact, detect the trajectories to see the ones of a lower background, if you see it from an economic point of view. But the extreme is, this group cannot move upwards. If you're on the richest level, any interaction with anyone else will be positive, negative, sorry. And in this case, if you live in the poorest neighborhood in Stockholm, any mobility will reduce your segregation levels. The interesting part is these ones, where you have an increase of negative segregation. What you see in some of the neighborhoods, which is more distressing, I would say, up here, is that you have neighborhoods where you literally have no employment, and the few individuals that move to a local school or local cafes in a local small part of the area, which then is being sort of where all the unemployed and all the kids in the area stay during the day. So you've got no interaction with anyone else, but all the unemployed tend to go there during the day. So it concentrates poverty. But it can only happen there. It can't happen there. Because that's the minimum, right? And this is the maximum. You can't move in any direction from it. Was that a good explanation, or was it an okay explanation?
Yes. Yes. Thank you.
Good. This is literally it. So, any more questions?
So the idea then is to maybe use these insights as a way to do recommendations for public policy, or
Yes. Yes. Yes.
we kind of anticipate this outside of Chicago problem, but
Avoid. Yeah.
future Swedish rap music.
Yeah.
So I was going to say something else, like your data sets, the mind and place. Can we?
Yeah. Sure.
Do you know the URL for this?
For mine, oh, it's a kind of a crappy one, isn't it? Let me see. Yeah, why not? That's the one. The mine database. There's not much information about it there, but yes, it is. Mind is the name of the research database that we are using. The Mind database, it's important to say, has been ethically tested and approved. And we are working sort of very hard to make it impossible to trace individuals over long time periods to actually make it work also after the transition of the GDPR, which is interesting. But the opportunity of this data set is tremendous because it is a data set that is not a cool data set. Usually when it comes to mobile phones, it's something called CDR. This is not. We've got a network data set, which means that we actually could follow the silent handovers between telephone masts, so we can follow individuals. So we've got a substantial number of individuals, well, literally between 1 and 2 million individuals on a daily basis. I am not allowed to say how many because I'm not allowed to share what company it is. They want some secrets. If I sort of reveal too much, they are afraid that their sort of industry secrets and stuff will be spilled over. So that's where we're not sharing it. But the information is legit and everything like that. And we can follow this for then longer time periods. So we've got these kinds of statistics for days and weeks, but then again, we can't monitor any specific individual for more than 24 hours. We don't want to do that for ethics reasons. We don't want to find that repetitive pattern of individuals moving in and out. So we have to treat longer durations, newer dates, as if there were new individuals in new contexts. The only thing that we can sort of train is the location, how people depart and come back, and treat any location, origin, and destination in some way.
And how many years into the class?
It's literally 2 years of data. But then again, I mean, this is also something that's important to say. We do not unpack. There's much of material that we simply don't use for ethical reasons because we are not allowed to use it. So don't see us as having a 2-year data set of data because we simply don't. This is so many restrictions from an ethical point of view. But it literally grows with between 200 and 350 million events a day. So it's a lot of events taking place. And multiply that with a few years and you can see the magnitude of things, and then you've got a variety of variables saying what kind of activity it is. We've got no information about the individual. We've got no information about nothing, the handler of the phone, thankfully. We only do spatial association where we try to assign the phone with a specific location where we think the individual might be living or for the day, and that location could be categorized as being an area of poverty or wealth or close to the water or anything like that. The next day we have to redo it, right? But these kinds of behavior are then being used and trained. If we did more than that and we had any information about the individuals, we would be in ethical serious problems. And of course we don't want that to happen. The other data set, the place data set, we only got very crude data materials. I could, in fact, I think that's what you're looking for. Okay, thank you. The place data set is an interesting one. Uppsala University and a few others has got kind of a unique data set opportunity where we got longitudinal discrete data from 1990 to, in our case, 2014. So it's a little bit outdated now, but hopefully prolonged and longer date. Where we got all individuals in Sweden that resides in Sweden. And the statistics comprise, I would say, something like a range of 80, 90 variables of unemployment, level of education, civic status, civil status. There are codes for literally everything. And we do have geocoded. We got material, yes, that's the Statistics Sweden version of it. We literally have geocoded material at 100 times 100 meter level. This is not provided anymore by Statistics Sweden for security reasons. Some people get it for 250 meters, and others get it only for some areas, which are a terrible geographical distribution. Statistics Sweden have been distributing for a long time. Really kind of a bad one. Lots of variability problem. The type value of individuals is in fact 0, followed by 1. So it's not a good distribution. We do have information about, again, education, unemployment, who they live with, and where they do, and what kinds of incomes they've got. And knowing this over a number of years, we could enrich either the mobile phone mobility data, where we know what kinds of individuals tend to move, and by looking at the change over the years, we can also say something about the material of the data, saying something like, this area is moving towards, it's becoming gentrified. It's not becoming gentrified, it's getting poorer over time, it's getting wealthier over time. So you can see processes from the registry data, and then combine it. But then again, this is once a year record. It's like census in the US or the UK or anywhere else where you do it on a 10-year basis. And this is again 1-year basis, but still, you've got a lot of individuals that are supposed to live in upper part of Sweden, but in fact work in the southern part of Sweden with very low salaries. Doesn't make sense. I think I end there, in fact. Is that okay? Or any questions, guys?
Well, let's thank John. We have time for a couple of questions.
Sure. When you collected the data for the Scalable, what kind of service are they using where you actually get those kind of types of data?
You mean these ones?
No, for the one
for the mobile phones.
Yes.
Yeah. It is the mobile phone service provider company itself. So it is not GPS or anything. We haven't got that accuracy of the coordinates. Literally, what it is when you have a service, for instance, not only a call or text message or download or upload of any data, but also the connection, you have to move to the next mast, right? Because of the next server. What is in fact happening is that the company stores for a short while your number and what mast is being assigned to. And the reason is, of course, that this is sort of a temporal kind of thing. If someone else wants to know where you are, you don't ask the entire network. You know in a database that your phone is there. So this is then listed as you move over the day. So that kind of information is being kept by a short sort of time period by this company. And it's in the end of the day aggregated to 5-minute intervals. So you can have multiple sort of events happening within a 5-minute interval. And mobility, but I don't know exactly when it happened, but I can see trajectory of different masts being involved. For instance, if you speed through a city, you can have 6, 7 masts, or 7 or even 10 masts. And also, if you walk in a street in Stockholm, for instance, where the masts are very close to each other, you might even, I've seen an example of this where we have probes of it. We go to one part of the office, we have one mast, and the other part of the office, we have the other one. Those are extreme cases, but in most cases you have got less sort of accuracy. And if you go to the rural areas, you've got one mast providing the entire village of service. Then you can't see any mobility because there's just the same mast all the time. But this is what it is, connected to mast, and find out the geography of the mast.
So are you aware of this paper 2 or 3 years ago in the archive think it was Israelis who did this, I'm not sure, or maybe guys at Carnegie Mellon. They actually took exactly this mass data,
Yeah.
and then they showed that it's trivial to take your cell phone and do the standard routes on the bike, on the car, by foot, and then use that to actually completely reverse engineer to a very high accuracy actual trajectories. Right, so that's I mean, it's not that you. So your data is secure, so people can't take it and do these things.
No. And there's two things to it. I mean, even though it is true, I'm familiar with the paper. For instance, Sweden is completely different ballpark in a sense because Sweden is very remote. Israel is by the opposite, or a very densely populated area, and there are villages literally everywhere. So if you go from these areas, I don't know, this probably has got 4 or 5 masts in the Ångström area, so in the buildings surrounding us. So when we move around from coming into the main entrance to here, we'll probably have got 2 masts that sort of indicate that we are in, I don't know, something like a 300-400 meter kind of radius or something. But given the nature of this day's position, we've got lots of individuals, it's difficult for me. But if I start moving, I can start tracing myself. But when we forget something, what we do then is the individual is in fact knowing his or her position and is controlling it back to the material. If you want to do it the other way around, and you want to find the individual that is doing a bike route, you have to redo the calculations for every single individual. And it's actually a tremendous amount of work that has it makes it literally unfeasible and unpractical. It's much easier to just put a GPS recorder on the bike and let him bike around and following after it. Or simply call him or something. That's a silly answer perhaps, but it is much more difficult than it seems.
I mean, these problems with guaranteeing local privacy are pure math problems right now.
Yes.
These operators are called lumped Markov chains. We'll study them in the foundations course. But Fika is ready, so let's thank John again.
Thank you.